Feel like burning your opponents to ash? Going shopping for ingredients for a nuclear bomb? Let's just get some information about it. In 1905, when Albert Einstein came up with the most famous equation, energy equals mass times the speed of light squared, what Einstein really meant was everything around us is nothing but energy in different forms. So it is possible to convert this matter to energy and vice versa. Matter is just a condensed version of energy. We can picture this by thinking about water and steam. You heat up water and it becomes steam. You cool it down and it becomes water again. It takes a lot of steam to just get a few drops of water, but only a few liters of water to get a room full of steam. Same is true in the case of the atomic bomb used to destroy Hiroshima, which required only 600 milligrams of uranium, less than the weight of a dime. Only 600 milligrams of uranium generated the energy to kill 140,000 people. Converting matter to energy is tricky. The sun does it naturally using a process called fusion. The sun, which is a huge sphere of mostly hydrogen gas, has intense pressure and heat at its core. This heat and pressure causes the hydrogen atom to fuse together to create helium and release energy. But creating such an environment on Earth is not easy. The atomic bomb uses another process called fission. Instead of fusing atoms together, in the fission reaction process, they are split into pieces. For example, when a neutron hits an atom of radioactive fissile material like uranium, the atoms split into two smaller ones, and some energy is released. And if the right type of uranium is used, the split will produce more neutrons capable of splitting more uranium atoms. This continuous process is called a chain reaction. If this reaction is in controlled levels, the energy produced is also in a controlled manner. This is what happens in nuclear power plants, where this controlled energy is used to generate electricity. If the reaction is uncontrolled, we get a nuclear explosion. So now that you know the basics, let's get to the ingredients we require. To fuel the atomic bomb, we will need uranium-235 or plutonium-239. These materials are highly radioactive, which means they constantly shred the neutrons required to split atoms and generate energy. So let's wear gloves. These materials must be held in a compressed state long enough to make the explosion. There are two approaches for doing this. The first one is the gun method. The gun is considered the simplest way to build a nuclear weapon. The weapons consist of a tube in which one half of the nuclear charge is fixed at one end and the other half is at the opposite end. An explosive is placed behind the other half of the nuclear material. When the explosion is detonated, the nuclear charge races down to the other end. Once these two halves meet, the chain reaction starts and the explosion takes place. The second approach is the implosion method. In this approach, the nuclear fuel is shaped into a sphere called the pit, and the explosives are placed around it. When these explosives are detonated, the force squeezes the pit and the explosion takes place. The explosion should be placed in such a manner that the shock waves generated should be precisely spherical in shape and detonate at the same time. These designs also require an initiator to flood the pit with neutrons before detonation. With this information, you can easily build a
How does a nuclear power plant break uranium, the 235, to become the barium, Krypton, and the neutron, as well as the heat energy to produce steam to turn on the turbine and the generator to get the electricity? A neutron collides with uranium 235 atom causing it to split into the fission, the smaller atoms like the barium 137.3 and the Krypton 83.79, releasing the additional neutron and a larger amount of energy as heat and radiation. These newly released neutron go on to heat other uranium 235 atom, creating a controlled the nuclear chain reaction that generates a continuous supply of heat. This heat is then used in a power plant to boil water, create the stream, and drive the turbine and the generator to produce electricity. The chain reaction, the subtended reaction, the neutrons released from the first fission and can go on to strike the other U-235 atoms, causing them to the fission and release more neutrons. Control the process in a nuclear reactor. This process is carefully controlled to maintain a sustained the self-perpetuating chain reaction, providing a continuous and predictable source of heat. Energy conversion, heat generation. The heat generated by the controlled chain reaction is used to heat water in the reactor. Electricity production. The superheated water then create high pressure steam that drive the turbine and the generator, which is the turned power a generator to produce the electricity. How to make an atomic bomb to make it explosion? We need to make a situation over a point of the critical mass and the critical density condition to make it explosion. After explosion, its heat will make two heavy hydrogens to fuse to become the one helium, to release the huge energy to become a hydrogen bomb. How to concentrate the element of uranium? We need a centrifuge to concentrate the elements of uranium. How to make an atomic bomb to make it explosion? We need to make a situation over a point of the critical mass and the critical density condition to make it explosion. Then and now, how Hiroshima and Nagasaki look after 80 years of destruction. How to concentrate the elements of the uranium? Centrifuge can't directly concentrate the uranium 235 in water. Instead, uranium must first be converted into a gaseous compound. Uranium has fluoride to be enriched in a centrifuge. The UF6 gas is spun at a high speed, causing the slightly heavier molecules the containing uranium 238 to move to the outside of the centrifuge cylinder, while the lighter molecule with the uranium 235 collected near the center and are drawn off. This process is repeated in the cascade of the thousands of the centrifuges to achieve the desired concentration of uranium 235. What is the difference between the light hydrogen and the heavy hydrogen? The difference between light hydrogen and heavy hydrogen lies in the number of the neutrons in the nucleus of the hydrogen atom. The light, the hydrogen, the proton, the symbol H, the proton, the 1, neutron 0, the electron 1, mass number 1. The abundance, the 99.98 of the nature hydrogen, also all known as the protein. The use is common in most chemical reactions involving hydrogen. The heavy hydrogen, deuterium, the symbol H2 or D. The protons 1, neutron 1, the electron 1, mass number 2, the abundance, the 0.02% of natural nitrogen, also known as the deuterium. The use the nuclear fusion, tracing in the chemical and the biological studies. The heavy water, D2O. 如何浓缩铀元素？离心机无法直接浓缩水中的铀235，相反的，必须先将铀转化为气态化合物6氟化铀，才能在离心机中进行浓缩。UF6 气体高速旋转。导致含有铀238的稍重的分子移动到离心机圆筒的外部，而含有铀235的较轻的分子则聚集在中心附近被抽除。该过程在数千台的离心机的瀑布中重复进行，以达到所需要的铀235的浓度。The periodic table of the elements. 这个元素周期表。